Chapter 10. Hypothesis Testing. Hypothesis testing is a major part of business statistics. Statistical hypothesis testing provides managers with a structured analytical method for making decisions where a claim about a population parameter is tested using a sample statistic in a way that incorporates the potential for sampling error. By providing a structured approach, statistical hypothesis testing allows decision makers to identify and control the level of uncertainty associated with making decisions about a population based on a sample. Hypothesis tests for means. In hypothesis testing, two hypotheses are formulated: the null hypothesis and the alternative hypothesis. The null hypothesis is a statement about the population parameter which will be rejected only if the sample data provide substantial contradictory evidence. The null hypothesis always contains an equality sign. The alternative hypothesis is a statement that contains all population values not included in the null hypothesis. If the null hypothesis is rejected, then the alternative hypothesis is deemed to be true. It is important to specify the null and alternative hypotheses correctly so that the results obtained from the test are not misleading. Because of sampling error, two possible errors can occur when a hypothesis is tested: type I and type II errors. A type I error occurs when the null hypothesis is rejected, when, in fact, it is true. The maximum allowable probability of committing a type I statistical error is called the significance level. The significance level is specified by the decision maker conducting the test. A type II error occurs when the decision maker fails to reject the null hypothesis when it is, in fact, false. Controlling for this type of error is more difficult than controlling for the probability of committing a type I error. Once the null and alternative hypotheses have been stated and the significance level specified, the decision maker must then determine the critical value. The critical value is the value corresponding to a significance level that determines those test statistics that lead to rejecting the null hypothesis and those that lead to not rejecting the null hypothesis. A test statistic is then calculated from the sample data and compared to the critical value. A decision regarding whether to reject or to not reject the null hypothesis is then made. In many cases, especially where hypothesis testing is conducted using a computer, a p-value is often used to test hypotheses. The p-value is the probability, assuming that the null hypothesis is true, of obtaining a test statistic at least as extreme as the test statistic calculated from the sample. If the p-value is smaller than the significance level, then the null hypothesis is rejected. Hypothesis tests may be either one-tailed or two-tailed. A one-tailed test is a hypothesis test in which the entire rejection region is located in one tail of the sampling distribution. A two-tailed test is a hypothesis test in which the entire rejection region is divided evenly into the two tails of the sampling distribution. Hypothesis tests for proportions. Hypotheses tests for a single population proportion follow the same steps as hypotheses tests for a single population mean. Those steps are: 1. State the null and alternative hypotheses in terms of the population parameter, now p instead of mu2. 2. The null hypothesis is a statement concerning the parameter that includes the equality sign. 3. The significance level specified by the decision maker determines the size of the rejection region. 4. The test can be a one- or two-tailed test, depending on how the alternative hypothesis is formulated. Type 2 errors. A type 2 error occurs when a false null hypothesis is accepted. The probability of committing a type 2 error is denoted by beta. Unfortunately, once the significance level for a hypothesis test has been specified, beta cannot also be specified. Rather, beta is a fixed value and all the decision maker can do is calculate it. However, beta is not a single value. Because a type 2 error occurs when a false null hypothesis is accepted, there is a beta value for each possible population value for which the null hypothesis is false. To calculate beta, the decision maker must first specify a what-if value for the true population parameter. Then, beta is computed before the sample is taken, so its value is not dependent on the sample outcome. The size of both alpha and beta can be simultaneously controlled if the decision maker is willing to increase the sample size. The probability that the hypothesis test will correctly reject the null hypothesis when the null hypothesis is false is referred to as the power of the test. The power of the test is computed as 1 beta. A power curve is a graph showing the probability that the hypothesis test will correctly reject a false null hypothesis for a range of possible true values for the population parameter. Conclusion. Many decision-making applications require that a hypothesis test of a single population parameter be conducted. This chapter discusses how to conduct hypothesis tests of a single population mean and a single population proportion. The chapter has emphasized the importance of recognizing that when a hypothesis is tested, an error might occur. Statistical hypothesis testing provides managers with a structured analytical method for making decisions where a claim about a population parameter is tested using a sample statistic in a way that incorporates the potential for sampling error. Figure provides a flowchart for deciding which